किया नहीं, करूंगा इसके बाद। Rajat is light now.
5 engineering companies came together in 1895 to form the Engineering and Iron Trades Association. Driving the nascent industry, its members built iconic landmarks such as Howrah Bridge. The association crossed multiple milestones as it went on to build India as the Confederation of Indian Industry. In 1912, the first steel ingots in India were rolled out by a member of this association, and EITA was renamed IEA. In 1942, smaller Indian engineering companies formed the Engineering Association of India. The association further helped Indian industry emerge stronger after independence. In 1974, in a landmark move, the two engineering associations merged seamlessly to become the Association of Indian Engineering Industry, to set a new paradigm for growth through partnership. In 1975, when India looked for external engagement, the restructured association organized the first ever engineering trade fair, showcasing industry to the world. In 1977, AIEI opened its first overseas office in Saudi Arabia, connecting India to the world. When the first overseas company entered the auto sector in 1982, AIEI worked closely with it to build the ecosystem for a new industry. In 1983, the association initiated its first office building in New Delhi. 1986 saw the AIEI transform to the Confederation of Engineering Industry for addressing the entire manufacturing sector. In 1992, CEI emerged as the Confederation of Indian Industry for all industry. Worked in partnership with the government, it helps Indian industry meet the demands of globalization and competitiveness. As CII celebrated its centenary year in 1995, it grew stronger with new missions for excellence and for forging deeper bonds with society. Since then, CII has pioneered many new movements such as quality, green building, skill development and corporate social responsibility. CII has inspired Indian industry to achieve excellence and reach for ever higher attainments. Its engagement in fostering a conducive climate for doing business across multiple sectors has helped Indian industry emerge as a global leader in key dimensions. Today, CII works across 4 pillars. CII consolidates and presents analytical perspectives to foster growth across all sectors. Working closely with the union and state governments through its offices across India, it enables the industry to contribute to development. In competitiveness, CII enhances capabilities and competitiveness of enterprises through training, consulting, advice and awards. It conducts research for industry and the government. CII, through its network of 9 centers of excellence, engages across efficiency, sustainability and leadership. CII's Center of Excellence for Digital Transformation is helping small enterprises build their technology and digital capabilities for the next level of business. Under International and Business Development, CII works with counterpart organizations in over 130 countries to take Indian industry to new horizons. Its numerous business missions open up to opportunities for smaller enterprises, and it engages with leaders and governments across the world. Building a strong engagement with the community, CII works intensively in skill development, job fairs and career development, disaster relief and rehabilitation, women empowerment, water conservation, air pollution and many more. Since 1895, Indian industry has evolved with innovation, partnership and pioneering initiatives from daring entrepreneurs. For 125 years, as India's development institution, CII has partnered Indian industry on its extraordinary journey of success.
Rajat, proceed, please. Rajat, please mute yourself.
Hello everyone and welcome to today's session on CII Siemens Product Showcase session on Aura and Fleet Eye under the purview of Virtual AI India 2021 show. For next 30 minutes, our eminent speakers from Siemens will discuss in detail regarding the product, including the problem statements, solution approach, and results. Implementing advanced machine vision powered by AI for Industry 4.0 and beyond, I'm sure that delegates who join us for this exclusive session will leverage the Siemens solutions for similar use cases and problems. Now, I would like to introduce our today's presenter, Mr. Inderjit Kar, Chief Architect AI at Advanced Analytics, and Mr. Untitled Chatterjee, Senior Machine Learning Engineer. Inderjit has 16 years of analytic technical delivery experience, including experience in driving innovation across client as well as internal businesses and setting distributed machine learning teams across business units. He is an experienced leader responsible for influencing CXO decision making, transforming businesses into data-driven culture, identify new AI product requirement, solution design, client engagement, and vendor management for emerging technologies, which deals with machine learning, data science, IoT, analytics, and digital transformation. He is a proud owner of 7 patents in NLP, computer vision, and adversarial deep learning. He is leading a team of solution architects, project managers, and machine learning and full stack developers. He spearheads new opportunity assessment and provides AI and ML solutions for automotive, smart agriculture, mobility and transport, industrial manufacturing and IoT, smart cities, energy and infrastructure, and digital twins. He owns the research solution development, deployment of machine learning, artificial intelligence, analytics program, as well as research initiative for Siemens Advanta and its global clients, including India. Prior to Siemens, he was responsible for establishing AI architect practice and winning 3 major AI deals for his organizations, generating revenue of $65 million each. He is responsible for planning and spearheading emerging technology roadmap as well as undertake, buy or make decisions. He is an experienced chief data scientist with a demonstrated history of working in the machine learning and advanced analytics. He is a seasoned data science leader with hands-on experience in developing statistical machine learning and deep learning models. Prior to Siemens, he was worked for many industries, namely manufacturing, mobility, investment, banking, retail, CPG, healthcare insurance, BPO, and ITITS. Now let me introduce our next speaker, Mr. Anand Chatterjee. Mr. Anand Chatterjee is seasonal analytics professional with 6+ years of experience in the industry, working primarily in data science, machine learning, artificial intelligence, and advanced analytics. He is also a certified data scientist from IIT Bangalore. He is fulfilling the role of a senior machine learning engineer at Siemens, where he works to identify potential areas of AI implementation, converting business problems into AI data science problem, designed to design the solution and implement it. The areas of work are smart transportation, industrial manufacturing IoT, smart cities, etc. Before joining Siemens, Mr. Chatterjee was a part of Infosys, Accenture, and Little View Analytics, where he worked in banking domain, working in graph analytics and AML, fraud detection, and real-time predictive analytics. He has also worked as a machine learning consultant to an insurance giant, helping them take data-driven decisions and spearheading AI-based solutions for automatic claims settlement and other problem statements. Mr. Chatterjee was also a part of the YouTube data science team during his time at LV and delivered their global customer segmentation, multi-touch attribution solutions, and assisted the marketing team to take any or all data-driven decisions. To begin with session, may I invite our speakers, Mr. Anand Chatterjee and Indrajit Kar. Forum is all yours, sir.
Thank you so much. See, today we are going to present two solutions, and both are edge-based AI solution, and as well as they are advanced computer vision solution. One solution caters to your traceability in your industry 4.0 or manufacturing domains, and also quality inspection. How can we automate those quality inspections? How can we introduce machine vision in quality inspection, as well as how can you introduce machine vision in traceability? The second one would be more of a drone-based technology with computer vision and as well as numerical data. So we call this multimodal data fusion, and we get insights like intelligent decision making, which helps routing problems, which helps vision-based inferences. So I will hand it over to Anindya Chatterjee to start with Aura, which is our traceability and vision-based inspection solution. Anindya, the floor is yours.
Yeah, thank you, Indrajit, and thank you for the introduction. So today we are going to showcase two products, as Indrajit mentioned. One is the Aura, which is our AI-based content extractor and defect detector from Caster Industrial Part. The second use case that we are going to showcase is a Fleet Eye. It's an ADL AI-based solution for multiple cases that we're going to discuss later. So let's begin with Aura, which is our product on which is an AI-based content extractor and defect detector from Caster Industrial Parts. To start off, let's understand what is the business problem. So a major foundry and automotive company wants to read characters on their manufactured parts to establish traceability for audit and to enable successful recall of the damaged products from the market. So they had a current setup which included a Cognex Edge camera and a Google Lens, which was unable to detect the characters from that particular manufactured parts. The main reason there were a lot of challenges in defect identification as well as content extraction. So let us see what the challenges were in the current setup and how did we overcome it. So the first challenge was of character orientation, whereas the characters in that has to be extracted were not oriented in a straight line. The second is, if I'm going to extract something, I need to make sure that I have an area of attention, and the area of attention which I'm going to extract should be an alphanumeric code based on the business problem. There were many alphanumeric codes in that particular image or the particular manufactured parts, making it difficult to identify the area of attention detection. The third is the alignment of characters were not straight. There were excessive noise in the data. There was some images which has curvilinear arrangement of text. The area of interest was out of focus. There were, due to the casting process, there were merged characters, and there were rusted or degraded parts. Now there were a lot of problems here, challenges that were there in the existing setup and the data that is being provided. So let us see how it looks like, right? So instead of speaking or instead of giving so much of words, let's see how it looks like. So here, if you can see that the orientation is not straight for an optical character recognition problem. And if you can see, just so if you can see here that the orientation is not straight and it is rotated, making it difficult for the OCR to extract data. Here there is a perspective transformation which is required, making it in a straight line so that it's easier for an OCR to recognize. If you come here, you see that the padding between the characters are not consistent, as well as the alignment of characters are not same. There is some characters which it's not in a straight line. Then there is a curvilinear arrangement where you can see the area of extraction are in a curve, and which makes it difficult for any kind of machine vision systems to operate. The text which has to be recognized, if you can see here, the area of interest out of focus, and there are multiple alphanumeric codes in the images, and making it difficult for the detection system to identify which is the area of attention for my particular system. If you can put in focus here, you see that there are merged characters. You can see that it's very difficult for a human eye to even say with 100% confidence that whether this is a B or an 8, and whether this is a 6 or a 5. So this happens due to casting process where there are merged characters, making it difficult for systems to identify. And we can see there are merged, which becomes like similar characters. And here you can see that the characters are merged, and it creates a confusion for the system to identify the characters. So let us now understand what is the setup architecture that we had and what we have proposed. So there are three setup architectures that we have here. One is the solution to be deployed on an edge camera, and the image on the casted parts comes on a conveyor belt, and we have a Siemens Sematic HMI which will showcase the inference that is there in the edge camera. The second architecture is that we run inference on a semantic NPU system, which will run our computer vision solution, and then we have a HMI which will show the inference on the screen. The third setup is that we have a same camera, but instead of going for an edge-based solution on the device, we have a server which is an IPC server of Siemens, and which deployed with the solution, and there we can go ahead and we can run inference on this. So before even going to the content extractor part, let us understand what. So there is two parts of the solution. One is the content extractor, and the other is the defect detector and localizer. So the defect detector and localizer comes into play when there is a chance of the manufactured items where we have to run the OCR has any defect on it. So if there is any defect which is being identified on that particular parts, and we are supposed to run an optical character recognition on top of it. We have gone ahead and we have added one more layer where we have added a machine vision system to identify whether there's a defect on the part, and if there is a defect, we go ahead and we localize the defect for the users to identify where is the defect exactly on that particular casted part. Now, once there is a defect on this part, we can either go ahead with the optical character recognition flow, or we can stop and we can just return back saying that there is a defect and we need not go ahead with the OCR flow. That depends entirely on how we want to approach it, or rather how the clients wants to approach it. So this is where the main part comes, is the content extractor process flow. So as you can see, this is the actual manufactured item which is there, and it has a text on top of it, and this text needs to be extracted, but this text is not straight, and it's not possible for a traditional OCR algorithm or a traditional OCR solution to run and give proper inference on this particular image. So this is the entire process flow on top of it. I'll walk you through the entire process flow that we have. So first of all, once we have that image, we run an attention network which will determine an area of attention on that particular image, which will make sure that we have one area of attention on each image. Once we have extracted, once we have that area of attention, we run a proprietary orientation correction and geometric correction algorithm, which will orient that image properly, and will get that extracted part in a proper format for any kind of OCR to run. Once we have that, we have three parallel flows. We have integrated what is called a mixture of experts algorithm, and we have two parallel where we have one manager, as you can see, which is the gateway network, and we have two parallel experts. One is a custom trained OCR, and the other is a character classifier, where we have identified the characters, and it goes to a mixture of expert solution where where it works like a traditional mixture of experts do, and we have the weighted sum of the weights, and then we finally come out with the output. Once we have that output, it is not the end of the solution here. We kind of had one added layer of validation framework wherein we have a set of business rules for every client, where they kind of where the alphanumeric codes mean something, and there are certain positions in the alphanumeric codes which determine a certain, for maybe a manufactured year or a manufactured month, and what type of instrument it is, or what type of device it is. So all these things, all these business rules comes under the validation framework, and the validation framework outputs is the final output of the entire solution. Now this is one, we would like to show the extractor process flow for one more such thing, where we are extracting the same thing, where we're extracting parts from a casted part. We're extracting the information, and this is the same flow, and you can see how the flow works in this case as well. So these are the two. So we are going to show, so both of the solution is deployed on the Siemens MindSphere platform, and we have the custom OCR solution deployed, as well as a defect detector deployed on the Siemens MindSphere platform. So this is how the OCR platform, the mock screen of the OCR looks like. This is the content extractor, and this is the defect detector, where we pass in the raw image, and there is a detection, and there is the area of the defect localizer, which is working as expected. And then there are other analytics metrics which are there, like the number of reads in a particular day, and the number of defected items which has been detected in a particular day. And if you go to content extractor, how many images have we passed, how many characters have we recognized, and the character recognized rate, which is basically the number of characters divided by the equipment count. So this brings us to the end of Aura. So I'd like Indrajit to kind of walk you through the initial fleet type business cases, and
Sure.
how did we, and what is the architecture looking like?
Absolutely. Yeah. Thank you, Anindya, for the aura. So now that comes to a fleet eye. So we know that transportation logistics is an evolving market these days, and there are five case studies that I would like to share. Anindya, if you can move to the case study slide. And yes, so the first case study is, let's understand this. A mining company wants to leverage UAV to track their transportation vehicle. Now, why they want to track this vehicles is because the roads that these mining companies go through, or after mining the vehicles go through, is through a dense forest. And this is a case study for a short distance solution. So if there is a jam in this forested areas, then it becomes very difficult for someone to reach the place and understand the temporal spatial situation of the place. So what do? The only way to reach there is through an aerial route. The second use case is a major cement company wants to check few things before even starting their scheduled departures. What are those things? They want to identify if there are any accidents, they want to identify if there are any jams, and they want to take real-time inference, putting it through an algorithm. And also they want to understand, can they take an alternate route apart from the routes that's already assigned to them. The third use or the case study would be a road designing company wants to design a road, and these roads that they are designing are through a difficult terrains, so where they cannot go for a manual inspection, and then when they want a solution when they can do an aerial inspection. The fourth one, I would say that there we all know that right now telematics as well as predictive maintenance of vehicle has become very it's evolving these days. So that's one of the use cases. And the last one is a very interesting one, where a smart city wants to find an equilibrium between their green gas emission as well as from their from their greenery. So the greenery and green gas has to be in a good equilibrium in order to have that smart city kind of a enablement done. So in order to do that, these are all hard problems, as you can see. So what can we leverage situations or equipments like UAVs, fixed position, and OBDs? Definitely. However, understand this, that there are challenges. And as you can see, enabling AI and ML for transportation is challenging. So I will hand it over to Anindya, who will take you through the challenges of AI adoption and what is our one-stop solution that we have come up with.
Thank you, Indrajit. So as you can see that everyone wants to implement AI, but there is a certain challenges in AI adoption. So based on Forrester reports, we have seen that 74% of transportation customers wants to agree that AI is a competitive differentiator in transportation. 70% strongly agree that AI adoption will grow in the next 2 years, but 45% of them do not have the data, and 40% of them struggle to find the external advisors for AI with their industry experience. So this is one of the major challenge, as well as like customers that have always needed help with AI, they needed help with data collection and extracting business value from the data. So we have come up with a one-stop solution to all these problems. So this is the solution is which we are calling it as a Fleet Eye, which is a two-part hardware and software solution, which is the integrated software hardware and software solution. So as you can see that this is the visual data capture, real-time visual analytics and recommendation system that we have for where we have incorporated a device which is called as the Eye, which has a drone and a Raspberry Pi incorporated together, and it's a computer vision based AI camera which can be mounted on a UAV and installed as OBDs. So what are the use cases that we are trying to solve using this? We can solve intelligent congestion monitoring and forecasting. We can do road classification. We can find visual anomalies on the road. We can do live streaming. We can have a visual track and trace, which is where we can actually track the vehicles which is moving from point A to point B. We have something called as vehicle classification and counting. We can install, we can have an edge camera installed at a particular junction point in the road, trying to measure what is the congestion, and we can have the ratio of greenery versus congestion, and we can also have a AI-based route optimization and alternate route recommendation. We can do that using the entire solution that we have. So let us first see. So this is also a similar kind of a problem where we have a similar kind of a thing where we have deployed it on the Siemens MindSphere platform, where we have this is the vehicle diagnostic using predictive analytics metrics, the route recommendation, and the command center view of the entire solution. So if you see on the left, you can see that there is a vehicle moving from point A to point B, and we can get an ETA for the source and the destination. There is also an AI-powered route optimization, which will take into account the multiple factors is there in the road and provide a route optimization solution. There are other operational metrics like ETA from source to destination. There is outbound logistics status, which is our tactical metrics, and there is also AI-powered visual analytics tool, in which we have incorporated our system, where we have determined what is the congestion looking like. We have also, if you point your attention to the right, so we have a live stream, and then we have a congestion view of that particular junction, where we have installed a fixed position camera, or we can use an UAV based on the requirement of the client. And we have a visual analytics where we are predicting metrics like traffic density, where we are predicting metrics like time taken to clear the particular congestion, and also a predictive maintenance as to when will the next congestion happen based on previous or historical data that we have. Now, this is the ground level command center connectivity architecture that we have, where we have something at the ground level, and then connectivity, and then infrastructure and security and presentation layer of that particular solution. Coming to a very interesting use case, as Indrajit was mentioning, is that can we impact environmental sustainability using AI? So as you may have known that the world is moving towards the goal is to keep a low carbon level in the entire city. So whenever there's a new smart city which is going on, or there's a new city design which is going on, so everybody has its own environmental compliance norms to kind of reduce carbon emission, or to kind of reach at a state where the traffic congestion and greenery content in that particular area, or the greenhouse or the carbon emission in a particular area and the green content in the particular area is at a state of an equilibrium. So what we have done is from that same live stream that we showcased earlier, from the same live stream, we have an AI-based algorithm which will detect the number of vehicles crossing over at that particular frame at a certain time. From this, the metrics, the derived metrics that we have can be fed to a function which will be a function, say for example, on traffic velocity and the traffic flow. And so the traffic flow metric, as you all know, is an inverse metric to the congestion, and these all metrics can be used in a function which will determine the carbon emission content in that particular junction. Finally, identifying the greenery in that particular area and calculating the ratio of greenery to the carbon emission can determine an equilibrium state of carbon emission to the greenery content, which is determined by our AI model. So how does it impact basically? So whenever there is some greenhouse emission, and whenever there is a situation where the system feels like the environmental compliance norms are not meeting, or there is certain where we see that the ratio between the greenery content and the carbon emission in the particular area is very low, then we go ahead and we raise alert to the city maintenance folks that your compliance norms are not met, and they can come ahead and they can manually go ahead and they can fix the congestion, or they can take necessary actions on top of it. So what is so basically covering now what is Fleet Eye doing for us? So the Fleet Eye, it's a 5-part solution, right? So it gives a real-time visual analytics as well as a recommendation for short business transportation operation, catering to medium, large, and small businesses. So during the beginning of the presentation, Indrajit mentioned that there are 5 problems that we are trying to solve, or there are 5 use cases that we have, and this is a one-stop solution which will use everything on top of AI as well as hardware that we have built and come up with a solution. So we are kind of summarizing the solution that we have. So solution 1 is a real-time visual analytics as well as recommendation for short distance transportation operations. Solution 2 is a machine learning based predictive analytics and recommendation for long distance transportation problems. Solution 3 is a IoT and ML based vehicle diagnostics, track and trace, and route optimization solution. Solution 4 is aiding road construction and design for difficult terrains using LiDAR. And solution 5 is creating social impact and contributing towards environmental sustainability using vision. So this is the complete a complete solution which we call as a Fleet Eye. So Indrajit, you have anything to add on Fleet Eye or Aura? Then you can go ahead and you can add any points that you want to add.
Has to be leveraged by our customers and clients as and when whatever they require, we will either build this as a package as is, or we have left our contacts, and feel free to get in touch with us. And over to you, Prateek, and thank you for having us.
Thank you, Mr. Anjit. Thank you, Mr. Chatterjee. I would like to thank our both speakers for their insightful presentation. I must mention our deep sense of appreciation for Mr. Indrajit and Mr. Chatterjee for giving this excellent coverage, and explanation to technology and solution. Indeed, it was very interesting and informative. So as all good things come to an end in life, so is the CII Siemens Product Showcase session. A digital event like this cannot happen overnight. The wheels started rolling 2 weeks ago. It requires planning and a bird's eye for details. On behalf of CII and Siemens, I take this opportunity to thank everyone, those who have directly and indirectly contributed to this session. At the outset, I express our appreciation and thank our eminent speakers, Mr. Indrajit Kar and Anindya Chatterjee, for giving excellent presentation on Siemens solutions for use cases and problems, and making this session a great success. A special thanks to my colleague, Mr. Pratim Mukherjee, for his unflinching support and coordination. Our heartfelt thanks to all delegates, not only for their active participation, but also sparing the available time with us today. With these warm words and a kind message, we move to the end of today's session. However, at the same time, we would like to announce the CII Siemens Masterclass on reinforcement learning for Industry 4.0 to be held on 22nd March 2021 at 14:30 hours. Do join us. Also, don't forget to visit virtual exhibition on AI India 2021, organized for AI Business Month on CI Hive platform by using the same link. The show is leading the way in shaping India's vision of technology leadership for inclusive growth, with a focus on leveraging AI for inclusive socio-economic growth, empowering 1 billion plus in line with the government policy of Atmanirbhar Bharat. This initiative of CII AI Business Month, AI India 2021, will play a critical role of catalyst in building a responsible AI ecosystem in India. Collaborate and scientize various experts, leaders, technology players, and other stakeholders to complement national strategy, public services, and other pressing priorities, and bring in investment to support the Make in India vision of the Honorable Prime Minister. Thank you, and wish you all healthy and safe week ahead. Goodbye and stay blessed.
Thank you.
Thank you, everyone. Bye bye.
Thank you.
Thank you.